Welcome to Turf Wars, where Harvard engineering students compete to see which group can build the best robot. Our robots have to be able to pick up debris, return the debris, and then park at the end of the round. Our robots have to be made out of stock parts, which we fabricate and then assemble in lab. The robot has to not get stuck on the turf, so there's a minimum ground clearance there. The robot also has to fit within size requirements. It should have enough power and speed to be able to score many points, and its intake-outtake has a capacity that, with a specified torque, will allow us to actually pick up the items. In order to be analytical, we used the Pew matrix to quantitatively assess which design we wanted to go with. We started with 3 concepts. Concept number 1 was the winner. Concept number 1 had an active intake along with a 4-bar linkage. The 4-bar linkage will ensure stability, and the active intake would ensure that the parts get picked up really quickly. Concept 2, while it could pick up a lot of things at once, had structural disadvantages in the connection between the intake-outtake and the main body. Concept number 3 failed because it could only pick up 1 item at a time. Therefore, concept number 1, with the best ability to achieve our goal, that is picking up items, was the design that we went with. Honestly, my favorite part might have been fabrication. We used lasers to cut acrylic, so 1/4 inch and 1/8 inch acrylic for our drivetrain and other things like our 4-bar intake. I also had some fun using my 3D printing skills. We made silicone molds, so we would pour silicone into them and then let them cast and dry in the casting. You can see me working on them here. The horizontal bandsaw was fun to use. We would take round or hex shaft stock parts and then cut them there for use in our robots. We would also use the drill machines and the CNC machines when possible. We did a lot of assembly using hand tools as well. We used engineering principles by validating that our robot would work with physical calculations before we worked on the gears, motors, etc. While fabricating this robot was fun, we did learn a lot of lessons, including being prepared for minor redesigns. We had to redesign our active intakes from small pinwheels to a large paddle wheel in order to be more efficient. So tournament day came and we woke up bright and early to get our robot working. You can see it worked quite well actually. In fact, our motors being taken from electric screwdrivers provided us in lab to dissect and use were working a little bit too well, and they had our robot being really fast. You can see here we just scored a goal. And of course, the more pieces and different kinds of pieces give different points we get inside of the turf, the better we do. I'd say that the main thing we learned was design. So we incorporated design ideas from experienced members who had done robotics before. For example, rubber band or zip ties for the active spin take, allowing it to be faster. This ended up being the silicone design that we implemented. We also better understood, and at least I better understood, how something is fabricated from scratch. So not just from like ready-to-made parts, but how to like fabricate it using like laser cutting from acrylic sheets or cutting stock parts like 1/4 inch stock and then using it there to our specified dimensions rather than ordering something custom. We learned how to 3D print, so we 3D printed our scoop. And so in the process of 3D printing, we learned that 3D printing can be used to also make casts for silicone, and so these manufacturing techniques all got integrated. Also learned how to do tolerancing and proper drawings, as we want to make sure that our machinists can always understand what exactly we're fabricating. I'd say that I really learned a lot and am much more confident in starting a project from scratch, thinking it through, and coming back even when it's hard and things look like they're falling apart, which sometimes it can feel like that. Personally, it was a pretty rough semester with me, as I had other final projects, other tests, other exams. There are days I would get to lab at 9 a.m. and leave at like 1, 2 a.m. and have to go all the way back to our main campus. But I'd say that I learned a lot, and I'm happy I took East 51, and I'm very happy to see what else I'll do at Harvard Engineering.